Welcome to various functions. So here's what I'm going to do. I'm going to walk through about, what do we got, 5 key functions, and it really makes it easier in this chapter if you've got a real good, almost memorization of where these functions are and some key points with these functions. So that's what I'm doing here. The first one should be very familiar to you, good old y equals x squared. But let me show you the strategy we're going to use. Basically, we want to get just enough key points in a table of values to refresh our memory what the graph looks like. So I'm going to put in, let's see, there's always, we could go 1 to the left, and then 0, 1 to the right, and maybe 1 more. It's probably good enough. Now, all we're doing is squaring the x's. So negative 1 squared becomes positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. If I put these points on the grid, there's 0, 0, negative 1, 1, positive 1, 1, and then positive 2 goes up 4. And of course, we know that parabolas are symmetrical, so we know there's going to be the same point over here. Let's finish it up here as best I can. We know it's a parabola, so we know we've got that basic shape. Whoopsie, that didn't go too well. Let's see if I can do a better job of it. I tell you, it looks easy enough on paper, but on this little drawing tablet, it's pretty tough to do a steady graph. Okay, good enough. It's our old buddy, the parabola, and that's our first graph. You know, you really just want to get to know these key points and be able to spit this out in a moment. Okay, let's go on to the next one. The next basic graph we want to look at is y equals x cubed, and I'm just going to grab my grid here. Let's move it a little bit to the side. Okay. And again, a few key points is all we will really need to get a pretty good idea what this graph is. Now we know there's good old 0, 0. We know there's 1 when cubed is 1, and negative 1 when cubed is still negative 1. If you look at those key points, it gives you your little framework here. Okay, and we could throw in, what if you threw in 2? You cube a 2 and you get 8. Well, it's going to be off my scale. It's way up here. So what that does tell us is that this is very, very steep growth. I mean, it goes roaring up, very, very steep. Okay, and basically the same thing over on the negative side. Drops very, very steeply. And there it is. There's our y equals x cubed graph. So let's clear the screen, and we'll look at the next one. Throw in a grid. Actually, I'll just put the function over here. Another familiar function. And hopefully you should find, hey, these aren't such a big deal. I've worked with these things for years, actually, so I should be able to do them quickly and easily. Like negative 1 turns positive, 0 stays 0, and 1 turns into positive 1. I guess it already was, but. And we know that absolute value graphs have a kind of a V shape. So, whoops, let's try and go through the point here. So more or less, there's the one side. Hey, why don't I use this line draw thing? There's an idea. And there's the other side, and so there it is. There's my absolute value graph. Again, pretty straightforward and stuff we've seen before. All right, let's do the next one here. And, whoops, there we go. Okay, the next one is y equals the square root of x. And again, going to use a table of values and a few key points. Okay, the first thing I notice is I can't actually put in negative numbers. Okay, there is a kind of a restriction here. these numbers all have to be greater than or equal to 0. So 0 is the smallest that I'm going to get, and the square root of 0 is 0. Then maybe a 1 is a good choice. Square root of 1 is 1. And then probably the next really good choice is 4, because the square root of 4 is 2. So it all starts here at 0, 0. Then I have 1, 1. And then I have 4, and then up 2. So I get this kind of a curve. Okay, what you actually have here, this is exactly the same shape as a parabola, okay, except this parabola opened up like this, and over here it's kind of like a parabola that's tilted on its side, kind of like that, and we only have the upper half. But that's the shape. It's actually like half of a parabola is what you kind of have. Okay, on to the last one. And let's throw the grid up. There's the grid. And here's our last one, 1 over x. So again, a few points in a table should help us to make sense of this graph. And we see there's one kind of a restriction. Looks like we can't plug in 0. Okay, and we know from work we've done in the past that there's more likely than not a vertical asymptote when x is 0. So that means there's really two parts or two halves to this graph. So here's some really easy points, something like -2, -1, and actually it's kind of a strange choice, but you'll see why in a moment, -1/2. And then I'm going to run through the positive versions of these guys just to show you what it all looks like. So if you plug in -2, you get -1/2. Okay, so that would be -2 goes down to -1/2. And then -1, if you plug that in, you get -1. Now here's where it gets kind of strange. If you plug in -1/2, you have 1 divided by -1/2. Okay, you actually have this. Now whether you use a calculator or maybe you just times the top and bottom by 2, you'll see you'll get a -1 on the bottom, you get 2 on the top, so you actually get -2. So here's what we have, -1, -1, and then -1/2 goes down to -2. And so here's what you have. Kind of this curved part here with a vertical asymptote being the y-axis. And then another curved part here with the x-axis being a horizontal asymptote. Now if I plug in the positive numbers, they're going to behave virtually the same way, okay, if I plug them in. So you're going to get kind of the same shape, but up here in the positive quadrant. So +1/2 goes up 2. Then I got 1, 1, and then 2 goes up 1/2. So here's what I got. Okay, try to draw this reasonable. There's our horizontal asymptote, and then it kind of roars up this way, and there's the vertical asymptote. And so that's our look at these 5 basic functions, and it really does help if you memorize them, be able to draw them without reaching for a calculator. And that's where I'm going to stop for now.